So try those two problems, and we'll talk about what the difference is. Part of the reason I'm putting this up here is they overload the word average. So I want you to see and realize, okay, average rate of change versus average value of the function. Felipe, how do I find the average rate of change? B minus A over the number?
Yeah, like
Okay, f of b, change in y over change in x, it's just slope. So f of 2 minus f of 0 over 2 minus 0, and we get a whopping 2. Sam, what's the difference? How do I do average value?
You use the 1 over b minus a.
So in this problem, what is
So
what do I
it'd
write?
be 1/2 times the integral from 0 to 2, or like, do you see the bottom going into the top or the top?
Bottom to the
You're from 0 to 2, 4x minus x squared dx, and that turns into what you got on the board, and then
you gotta do arithmetic. And Alex asked before people came in, like, so on the AP exam, could I just leave that? Yeah. Okay. You don't have to do all the arithmetic on the AP exam. For me, if you leave things like 2 times 4, I will mock you. 2 times the square root of 9, make that 6. Square root of 9, you know that's 3. Things that are not okay. Even if you've said somewhere else, f of 1 is 3, or if it's in a table, you need to know that you need to show that you know where to get that value, or how to get it. If this was, oh, and this thing was e to the 7th, like, you can leave that big ol' mess, but you needed to have evaluated, like, what is f of 1, what is f prime of 1 if it's somewhere on the paper? You gotta plug it in. Get the difference? So one, if you could have just typed the big ol' mess on a graphing calculator and gotten an answer, you're good. If you needed to look something up to be able to type it in, you're not good. That's the difference. It's been a while since we've done these, so so close. Doesn't quite fit. Gonna try and make it so, well, you can sort of see all three. Oh, you can see more than that. All right, try A, B, and C. Do you guys have answers that we should talk about? Or are you still working? Okay, resounding silence. All right. Use the table to approximate the rate at which the volume in the tank is changing at time 3. How do I do that, Lily?
Just you like set up an equation, like, I'm not sure if I did it right. You like set up like a slope equation using the values of 1 and, like the values of 1 and 4, because like 3 is in between them. So you find the slope, and that's gonna be -9.
Okay, so notationally, like, what are you finding? Well, the rate of change of the volume, they're calling it L for, I don't know, leaking tank, I don't know, but it's L prime. And the Y values over the change in the X values, so -27/3, -9. And it didn't ask for units, but I'm gonna ask it for each one of these. So what these words say. For part A, using correct units, explain the meaning of this expression in context of the problem here. So Ben, what would you say that -9 stands for?
Gallons per hour.
Okay? In context of the thing, so it meets a sentence. So it is
Oh, yeah.
-9 gallons per hour, I agree.
It's in the water's draining out of the tank at a rate of 9 gallons per hour.
Okay,
That's
still,
equals 30.
I like it. They want a noun, the unit of time, and, noun, the units, and then the time. So, at the 3rd hour, the water is draining out at 9 gallons per hour. And if you've ever seen water leaking from stuff, if it's full and it pops a leak, it's coming out a lot faster than when it's like almost empty. It's kind of dribbling out at the end. Okay. Evelyn, how about B? How do I start B?
Well, really, isn't it just, because it's like
The integral of the derivative is, yeah, L. So 110 minus 210, -100. What are the units, and Francesca, what are the units and what does it mean?
the units are in gallon. And it means in 12 hours it lost 100. Wait.
Do you guys agree with that? That in 12 hours, the tank lost 100 gallons of water. Okay. So I had to grade one of these last year. And if the students didn't say gallons of gas going into the car tank, they didn't give it to them. I personally will not take points off for that, but they might be picky if you didn't say I'm sorry, Andy, if you didn't say gallons of water. Gallons of what? Well, are you kidding me? The thing was going in the car. They're like, nope. You needed to say it was gas, not ethanol or something. Irritating, but there it is. So yeah, and don't be confused. Like, everyone was like, well, isn't the integral of the just that? Like, is it that easy? Is it just out? Mm-hmm, it is. This one, using LRAM to evaluate, which I'm gonna need space. Constantine, what do I write?
I did 1/12 times, and then like parentheses, I did 210 plus 190 times 3 plus 163 times 8.
Okay, so be careful. DX changes in this case. Often it's uniform, it's the same amount, and you can factor it out and it makes the math easy. This one, they were different. And it was LREM, so he chose the left end as the height for each of these, times the DX. And Alex, again, on the AP exam, you can stop there. And the numbers, they're yucky, they're not that yucky. Something like that, it was like 2,400 and something over 12, and it reduced by 4. But, on the exam, they absolutely insist on seeing the numbers that you are plugging in, yeah.
Once you get the fraction, do you have to simplify?
Mm-mm.
Yeah.
So in context of the problem, what does this mean?
Average, water in the tank.
Okay, use more words.
Average water in the tank between time 0 and time 12.
So over the 12 hours, the number of gallons of water in the tank was about 176 point whatever gallons. But yeah, it's the average water level over 12 hours. Was it ever that height? Exactly once, because it doesn't look like it's being added to. Okay, so those were some things I wanted to make sure we touched up on. Did you guys have specific questions from the chapter review or any of the optional stuff from Delta Math? No, okay. Not asking you to do them, but let's just look at these. 15. You guys know the answer fast? 20. So it's a height of 5 over 4 units. And you do that fast now, and later in the year, you're going to integrate it and do it the long way. That's fine. I mean, cool. My concern is that now, if I was to ask you this, you guys would integrate that by the graph or whatever, and then you would just add 5. So be careful that, like, if it's by itself, you guys do the integration of the constant correctly. But if it's being added on at the end, you suddenly don't. So if you need to split it up to get it right, do that. Do the rest of these look reasonable? What about the last one?
That's not appropriate.
Constantine, you know?
This isn't a tangent.
Isn't a tangent. So we haven't talked about this one a lot, but, and the reason this came up is someone asked, do we need to remember these and know those? I showed them to you and asked you to write them down. When we do chapter 6, which is next, we'll learn how to integrate this easily and you don't have to memorize it. So I don't want you to memorize things that you can create and derive on your own later. This one is just a no. Whose derivative is secant squared? Ah, I remember tangent. And then to evaluate it, do you guys remember unit circle? It's been a minute.
Yeah, it was,
So just draw the triangle every time.
Yeah, okay. How do you draw your triangle?
Like the 1, 2, over 3, and then pi over 3 at the right, and pi over 6.
Okay. Across 3 is root 3, 1, 2. Okay, so what is tangent of pi over 3?
Root 3.
Root 3. What is tangent of 0?
0.
Okay. totally amuses me. Happened in first period, people were doing their like unit circle gang signs, they're like waving their arms around.
Who was doing that?
The half the class, they were like, because tangent is y over x, that's why they were doing this.
Yo.
And Melissa, forever ago, Melissa was like, 1 over root 3, 1 over root 2, she, I don't know. But, so tangent of 0 is 0 over 1, y over x. Cosine sine, alphabetical order, sine of negative pi over 2, negative 1, cosine of pi, negative 1. Secant of pi over 2, 1 over 0, oh, that's undefined. Cotangent of negative pi over 2, negative 1 over 0 is undefined. Like, know the two triangles, oh, what's the other triangle?
1, 45, 45,
45, 45, 90. Secant of pi over 4, root 2. Cosecant of pi over 4, also root 2. Okay. Just checking. You're okay with fractional exponents, raise the power? Raising the power from there is,
Negative 1/3.
and then divide by the new power.
Times
Three.
the, yeah, negative 3.
Okay, just checking. Looking at this, I'm like, you guys don't know how to do 25 yet?
Isn't it just chain roll, like reverse chain roll?
Yeah? So what would you say?
I would increase the power of the bottom thing by 1, so it's negative 2, and divide by the new power, so it's divided by negative 2. And then I'd multiply it by the stuff that's inside, so it would be 2x plus 1.
Super close,
Or divide by the stuff that's inside.
super close. But no,
Ah.
hold that thought, that's chapter 6. So, doing 25 right now, I am hoping the textbook said to use a calculator, cause, I don't know. But Andy, very, very close. Can you guys try
Multiply.
those two?
You gotta add that.
I gotta add that, yo. Just to tick you off.
No.
I'm just counting it.
Just like over any tool. Feel the world.
It's cosine of 2. Cosine of 2. Yeah, that's. Oh, wait. It's just a bucket. First was that, and then come back. It is, yeah.
So you don't even have to.
Paolo, pick one. Can you put the solution up? Okay.
You could factor it.
But you can't.
Miss Pascal, no, up there, that's the answer.
No?
Annika, could you do the second one? No? Andy, you wanna do the second one?
Ready for this stroke of math genius.
Okay.
This isn't like distributed yet, this is just like. Okay, nothing else.
I
What's the
can't see
first
it, so-
step?
it doesn't show on my side, so I don't know. Paolo, the first one, come on.
I didn't know this was the first one. I was just doing the second one, I was like lost.
Suppose that's the first step, eh? Whoa. Is that it? No. It's doing math. Wait. Yeah.
Okay. Let's look at these. So it asked, and it's scrolled off, but it asked you to do the derivative of these
Oh, it
integrals.
did?
Yeah,
Oh, that's what I was
Oh,
Bro, I didn't realize he was asking.
so it,
Fundamental theory of calculus. Well, yeah, bro, if I saw the derivative,
So-
I did that easy.
the derivative of the integral
Bro, if there's a variable, then.
is the stuff in there
That makes it so much
times the derivative of stuff. Okay, so in the first one, the stuff was x, derivative of x is 1. Now minus plugging in the 2, but then the derivative of 2 is 0, so I'm going to stop there. That's the answer. The second one, the derivative of the integral is the stuff inside, this stuff, with the new limit plugged in, and then chain rule, 14x, minus the stuff with that new bit plugged in. Not different enough. Chain rule.
So we didn't get it
Mhm. But if you didn't know you were doing the derivative, that's a problem.
right. I didn't know that. I was confused. Bro, if there's a variable, how would have done it?
Yeah, so it's like.
So then obviously.
Sorry.
Those are so easy ones. I didn't want to.
We're just You're just making it so much easier.
It makes
I
it a
thought
lot
that was like
easier
a
to see
Um,
if there's just a
I think we can do it the normal way.
Let's see,
Yeah, but.
even when we get to fancy integration, you can't do this. Yeah, like, you cannot integrate it. You can do the derivative of the integral, sure, but integrating it, I'd be like, you gotta type it in on a calculator, and if they're not actual numbers, you can't do it. Speaking of calculator, okay, at some point, I need to give you guys something that assesses how you can work on the calculator. I had a worksheet before Thanksgiving that a few people optionally took that compares Desmos to your graphing calculator. I don't care which one you use, but you need to be able to perform certain math operations on those guys. So the 2 days before winter break, I'm thinking are fun with calculator day. Some of you won't be here, but we'll work on how to do all the things on the calculator and compare with Desmos and see what you're good at. Do all of you have a graphing calculator of
Yes.
some sort?
Yeah.
No, anyone does not have a graphing calculator? Okay, So those 2 days, we will play with the calculator, and at some point before the end of this semester, we will have some kind of assessment with random math using the calculator. Like integrate this, and, you know,
It'll be a fun number.
yeah? Integrate that from 0 to 19, like what is that? I don't even know.
What's the purpose of doing that then?
Because on the actual AP exam, last year my students were like, yo, we never practiced with Desmos, and I was like, that's because I didn't know that it was gonna be a thing. I didn't know that they had access and stuff. So, I need you to know how to use Desmos so that you can, because they actually have sort of real scientific equations on there, and let me tell you, real world is not nice, so they're ugly equations that don't integrate well. So students do need to integrate and then do some analysis with the number. Like, okay, in context of this question, what's happening?
Okay.
Is the amount of grain in the bin increasing or decreasing? Because there's a certain amount that's rotting and a certain amount that's being added fresh, so what's going on? And these rate in, rate out questions they will ask. So you need to be able to use the calculator. Other stuff. Okay. Is there something in particular you guys wanna make sure we go over before your test tomorrow? Yeah?
Aren't you like finding these specific values, with like the mean value theorem? 'Cause we did a lot of like finding the average, we didn't do a lot of like actually finding the values you've seen.
Okay. Find the average, and where does the average, I need an actual equation. Okay. So, the average value, whatever number we got out, where does the function equal that? Well, whatever number we got out, like that's all you do. And in this case, it's not gonna be a nice answer, and you need a calculator to solve it,
Yeah. Okay.
which is why I haven't been asking those so much.
Okay.
But they don't generally ask where does the
They
average.
don't? Okay.
I mean, and if they do, it should be kind of, sort of obvious in the question.
And then also like for the mean value theorem for derivatives, there's like requirements that it has to be like continuous and differential over an interval, but what are the requirements for integration?
That it can be integrated. Yeah. So.
Like if
it-
they ask us to, if you ask us to like prove it, like how would we do
They're not going to,
that? Oh, okay.
but if I ask you this, what is the average value? Why is it, it's a frowny face.
Undefined is here.
Can't integrate over the 0. Cause this is infinite discontinuity. What the heck is this area? And even with the symmetry of it, you can't say, oh, this infinite negative is gonna cancel with that infinite positive. Unless you run into a few of my professors and they argue about infinities meeting on the other side. Negative infinity and positive infinity, they go this way and they meet on the other side. Of what, Professor Solomon? You know, the other side. No,
Oh, yeah.
Professor Solomon, I do not know what you mean by the other side. He's like this.
Yeah, that is.
Over there.
I suppose you could do it if you're working with 3 dimensions.
Okay, well, and I did have spherical geometry with him, so parallel lines did intersect. And through a line and a point not on the line, there was an infinite lines parallel to it because you were in hyperbolic space because we kept breaking Euclid's rules. It was a little twisted, yeah.
Was his meet, like the other side, was that a quirky, weird teacher thing, or is that a fact?
He visualizes things like black hole space. So he saw negative infinity meeting positive infinity in a warped kind of wormhole, black hole kind of way.
So, no
Obviously.
longer a rectangular plane.
No,
Yeah.
like I said, had him for spherical geometry, and then we did hyperbolic, elliptical, toroid, or life on a donut.
That sounds just aggravating.
Like, the donut thing was not especially useful, but life on a ball, very useful, cause, I don't know, we live on a ball.
Yeah.
Navigation around, like, on the globe, when they show you flight routes, you're like, why the hell are we going to Kansas to go to the, well, do it, like, that was actually on the way. Gotta stop in Kansas. Right. Anyway,